My name is Sean Brown, and I am the Director of Public Health Applications at Pittsburgh Supercomputing Center with Carnegie Mellon, and I'd like to welcome all of you to our Bridge webinar today. The Bridge webinar is a joint webinar series by the McGill Center for Convergence and Health Economics and Johns Hopkins University and the Pittsburgh Supercomputing Center. It is designed to prepare for the next generation of big data analytics and to develop solutions by establishing bridges between sectorial big data and between data and content. So we're really excited to have a speaker along those lines. And just to announce that on August 2nd, we will be having our next webinar in the Bridge series, which will be Nathan Young. So we're really excited about him joining us as well. So I will turn it over to Mr. Lorette to introduce the speaker.
Thank you, Sean. I'm Laura Dubé from the McGill Center for the Convergence of Health and Economics, and I'm very pleased to host today Professor Athula Ginige, who is a professor of information technology at Western Sydney University in Australia, and he leads there the Social Computing and Knowledge Ecosystem Research Program at the School of Computing, Engineering and Mathematics. This program focuses on developing knowledge-driven solutions delivered via mobile-based system to a range of applied problems, including grand challenges ranging from agriculture with the small-scale farmer as well as other type of agriculture, up to working also with business solutions for enterprises, and more recently, which is of a lot of interest for our group who is interested in moving toward integrative digital technology, more recently also working in diabetes and healthcare. His current research area include both autonomous and participatory sensor networks, knowledge aggregation and event detection, large-scale organization based on ontology and semantic web technology, as well as various types of computer science modeling. His talk today is on, as I mentioned, on the digital knowledge ecosystem for agribusiness, transforming agriculture, very much kind of delving further here in work that he has been doing in the small-scale farmer space and progressively bringing us to the other dimension of his very fascinating and important work. Athula, shifting back to you.
Okay, thank you, Laurette, for that introduction. And good afternoon, everyone, and for some it is good morning. Yes, and I believe you can hear me all right?
Yeah.
Okay. So, as Laurette said, I'll share some of my experience and insight on an interesting journey I have been now going since 2010. And I'll first put that in context. If we take the 17 Sustainable Development Goals, or the SDGs, the shortened form, the first three are to deal with zero hunger, no poverty, good health and well-being. And if you really think of these three, the cornerstone for all these three is to have an effective food production and distribution system. Because without the food, yes, there is hunger, which is direct, but today if you look at the FAO report, etc., still in the developing world, about 75% of the people are livelihoods are someone connected to the food production system. And also if you look at some of the developed economies, they also had an effective food production system at the beginning, and then they moved on to other areas. And also you will see that the nutritional diet is again key to have a good health and well-being. And then you get the medicine side of it, but the diet plays a very important role in all these countries. So with that background, if we really look at some of the signs we see if we don't have an effective food production system, and as recently as last month, 7 June 2017, in BBC News, we saw that in India, the police have shot 7 farmers dead because they were rioting. Why they were rioting? Because they had a surplus, not a deficiency. They could sell the crops, harvest, but in the neighboring state, the government waived their debts or the loans, and these farmers were asking for the same. So when you say inefficient food production, that is the oversupply, undersupply, not right food type thing. Then the other one which actually helped us to start the journey was what we saw in Sri Lanka, where every 4 to 5 months, there is particular crop being overproduced, some underproduced, prices clash, farmers get trapped into poverty cycle. So in one part of the world, food gets wasted because of the uncoordinated systems. And in the other part of the world, there's malnutrition and people are starving. And then there's another form of starving which I will touch briefly towards the end of my presentation called hidden hunger. People are getting the necessary carbohydrates but not the micronutrients, and that leads to again stunt children and lots of health issues. So you can see the food is central to this whole 3 areas of zero hunger, no poverty, and health and well-being. And also, if you look at the world, some of the world food facts from production, storage, handling, processing, distribution, and consumption, again the reports indicate that in the emerging economies, 40% of the food gets wasted in the first part of the supply chain, and in the mature economies, 40% of the food gets wasted in the second part of the supply chain. And recently I saw a report from India, one of the ex-agriculture ministers saying that this 40% in India is 8.2 billion a year. So it's very substantial amount of food is getting wasted. People get stuck in poverty cycles. On the other side, people don't have enough food, malnutrition, which leads into lots of problems. So one of the key areas is if we can get this food production coordinated, then we can solve or address most of these major challenges. So that's sort of the background to what I'm going to present today. And if you take another view of this whole food production market, and if you look at the controls theory or systems theory, one will see this is a open loop system, because in the middle there is a balancing act of supply and demand, and that depends on multiple inputs, whether being one of the things which is very difficult to control but minimize the effect if we know the predictions, etc. Then the availability of money for farmers to buy the inputs at the right time, and the microfinance or the various financing systems come into play. But on the other hand, they need to get the right inputs, seeds, fertilizer on time. And on the other side, there's the markets which you should be able to buy these things. And if you really look at it, all these happen in a very uncoordinated way, and the governments are trying to balance this, which is the control input, if you look at a systems theory, through various incentives, subsidies, etc. But being an open loop system, you don't know what is going in the system until you see the output, which is the harvest. And very often either some things are overproduced, some things are underproduced, and food go waste. So with that backdrop, I'm going to talk about 2 things as how we came up with this a potential solution to this, and I have divided this talk into two parts. First, I will talk about the invention or the journey that led to discovery of digital knowledge ecosystem to coordinate agriculture market. Like, it was a very interesting journey. It just didn't come, this is the solution. And I'll share that, and then I will talk more the more interesting new developments, which is the innovation part of how we are now planning to take this invention to the real world or the marketplace to develop a value proposition for the agriculture domain stakeholders. So if I start with the invention part, that is a journey of about 6 years that led to the discovery of digital knowledge ecosystems to coordinate the market. Again, I'm not going to go into too much details here. It's huge. As you can see, this work has resulted in 4 PhDs, now all completed, 1 master's thesis, and then at the moment there are about 22 publications up till now, and still there's 2 more publications and a book to come on this work. So it's in some sense the invention part is now very much documented. I'll give an overview within about 20 minutes or so that I will have time to explore the insights we are now getting and the work we are doing in the innovation part of taking this invention to the, I don't like to call the marketplace, but to the agriculture domain, and see the issues and challenges we are facing in that area. So as I mentioned at the beginning, this whole journey started when we observed overproduction problem in Sri Lanka. And again, you can see in the newspapers, you find every few months reports saying, look guys, overproduction of, this time it was the tomatoes. Farmers, when they bring to the market, they find the prices have crashed and they didn't want to even take it back because that's another cost, they just dump it. Then another season it was leeks, carrots, tomatoes in different seasons, and this pattern continues. And this is not, as I said at the beginning, not limited to Sri Lanka. India, which is the second biggest populated country, is experiencing the same thing, and we saw some of that symptoms even as last month. And just to give a little bit of background to Sri Lanka, if you're not familiar, it's a small island which is at the south tip of India, population of 22 million, same as Australia. But some interesting facts are, by 2015, the total mobile connections has reached 117%. That means every person has got more than a mobile. And if you just take these children out of this equation, this could even be closer to the adults having about 2 mobile phones with these numbers. Also, it's a country which has a fairly high literacy rate. Actually, it's 92%, highest in Southeast Asia. And also, it has 3 major climatic zones and 7 agroecological zones, which will sort of govern what crops grow where. Are there any questions, or is that, oh, I'm good to continue?
Athula, I have everybody muted for now. We'll take questions at the end.
Okay. Yeah. So, in order to solve that problem, I managed to assemble an international collaborative research team, and I was working with University of Colombo in Sri Lanka, and the head of the department, Professor Grihan Vikramanayake, another senior lecturer, joined, and 2 people joined the team, and they have now done their PhDs on different aspects of this project. Then I had 3 universities in Australia joining the team, Western Sydney University together with Australian Catholic University and Macquarie University. And one PhD and a master's came from this team. And then we had University of Salerno in Italy that joined the team, and one of the PhDs on user interface design and most of the human-computer interaction work happened in Italy for this project. And the person who encouraged us is Professor Ramesh Jain at University of California, Irvine, and some of the early ideas and aggregation work, he had a lot of input to provide. So it was a truly international collaborative research team that assembled to solve this problem, and that made the journey very, very interesting. And the research approach that we used was design science research methodology. And basically, one can summarize it as having 3 cycles, which is a relevance cycle, a design cycle, and a rigor cycle. And this methodology is very useful if you are looking at creating an artifact. If you're only creating an intervention, we can use an approach like action research. But if you're going to create an artifact, design science research methodology seems to work quite well, where you move through these cycles at different stages. Normally, you start with a relevance cycle, going to the field, understanding the problem. Then you jump into a rigor cycle and looking at the literature. And once you have the literature, you go into a design cycle and start exploring some possible solutions to it. But that will be governed by what you learn in the relevance and the rigor cycle. And then you do some evaluation or internal validation of your artifact. You go back to relevance cycle and see whether your solution can solve the problem, whether it is relevant to the real world. And obviously, if you won't get it right in the first time, then you gather what is missing again, the top part of the relevance cycle. You can then jump back to the rigor cycle to look at the literature and gather some more data, design. And normally, you can jump anyway, say from relevance, you can come to design. And the important thing is, why I have shown this with these cogwheels is, when once you get used to it, once you are thinking of relevance cycle, same time in your mind you think of the design and the rigor, but all these wheels are turning at the same time but driven by relevance. And then another time, all these wheels are turning, but your driving force comes from the rigor cycle and the literature. And another time, all these wheels are turning, but your driving force is in the design where you're thinking how to create a solution to the problem. And with that methodology, we can map the journey we took from 2011 August to the September 2015, where we did a post-deployment evaluation of our artifact for this system that evolved. Again, with a relevance cycle, going to the field, interviewing the farmers, agriculture extension officers to understand the problem, and then a design cycle. Again, I have not shown the rigor cycles because everywhere we were looking at the literature, but mainly the interaction between design and relevance is shown in this journey. Rigor was happening in the background all the time. First, visualizing a conceptual solution, then realizing we need to create an ontological knowledge base, and then the question of why people should use this artifact, which led us to the whole exploration of user empowerment. And basically, these 3 areas evolved into the 4 PhDs, visualizing the solution and a PhD in HCI, but also the whole value proposition was in all these 3. Another PhD developing this ontological knowledge base, and another PhD on design for empowerment. And then we found that the knowledge is not only static, we want to get real-time knowledge as well, which is the generating dynamic content. And putting all that together, we did the first functional prototype, went back to the field and tested it. We found, yes, there are many changes needs to be done. Refined the architecture and the system. Went back to the field again in November 2013, tested it. And by that time, we realized, which I will explain in detail in my following slides, that this is an ecosystem, and it's a digital knowledge ecosystem. The reconceptualization happened around 2014. And in April 2015, we had a limited deployment to validate the system among the farmer community we were working, and we did a post-deployment evaluation in 2015. And then around 2016, the invention part sort of came to an end, and we moved on to the innovation part. And let me now take you through some of the issues we found in the invention part. The very first thing was we were trying to figure out why farmers decide, or how farmers decide what crops to grow. Because what we saw was the symptom and oversupply and their decision-making pattern, and to make those decisions, what information is available. And that is when we discovered that there is a very weak flow of information in the whole domain. Farmers get information from agriculture extension officers, sometimes through leaflets. There are television programs, but mainly from their ancestors. And then based on that, farmers make decisions. They don't know what other farmers are growing, whether a particular crop is being selected by many. And then the agriculture extension officers find out what farmers are growing. They collect and produce the data. They send it to their department, agriculture department. Then they aggregate and provide reports. But the reality is, by the time they know how much carrot is grown, the carrot has already come to the market. There is no way to make an intervention, and therefore system is not functioning in a stable way. And that led us, our researchers, to go and interview quite a few farmers, agriculture extension officers, to understand their decision-making pattern. And we did a causal analysis, and we found, yes, every farmer is revenue-driven, which is determined by selling price, which is determined by the yield quality, supply and demand. And identifying yield quality was interesting, because farmers have tried to grow hybrids, but using their knowledge they have got from their forefathers, and as a result, the yam they were too small, and they didn't get a market price. So for different varieties, there are different growing methods, and that was a problem for farmers. And the other thing is, because of the weather change, certain crops they were used to grow now don't grow, new crops grow. That knowledge is also not getting to them. And then we went another step and said yield quality depends on weather, pest diseases, fertilizer, new methods. Supply depends on another set of parameters. Demand depends on another set of parameters. And then we found this information is required at different stages, different formats. When you are choosing a crop, you need to know about what crops will grow in my farm, the disease resistance, the weather, and at the growing stage is more about fertilizer, etc. And in crop selling pattern, they need to know about the buyers in the market and what the prices are, but nothing much can be done at crop selling pattern area except for preserving the harvest. Whatever the major interventions has to happen when you are selecting a crop and growing it. And then we asked, where can farmers get this information, which led to another set of mappings here, where the crop varieties, seed production, etc. was from private sector, various seed sellers, some information from ministries, some information again from private sector, for different stages that we identified: crop selection, growing methods where the fertilizer information required, and also harvesting or selling stages. They want different information, and there are different providers. So typically information flow map has to be something like this, but they had something very different. A very weak information flow map, which I showed here. having understood this, we sort of realized the root cause is that farmers as well as other stakeholders in the agriculture domain not getting right information at the right time. And that is where we found that all stakeholders need context-specific actionable information. We introduced this notion of actionable because there was a lot of information in leaflets, websites, but people had to do a lot more processing to make use of that information. And broadly, that information is to do with scientific crop knowledge, which is changing slowly, and market information to coordinate the market, because when one particular crop getting saturated, farmers need to know that it is getting saturated so that they can start thinking of other crops. So we looked at farmer information needs in a lot more detail to generate this notion of actionable information, because we knew the information is there, but things what farmers wanted were, what are the suitable crops to grow in my farm? Again, personalized. What are the best varieties or cultivars? What are suitable fertilizer and quality? But they wanted answers to these questions at different stages of the life cycle. The important point is in a form where they can immediately act on it. Not a lot of information, websites, leaflets where they have to read and process, and that information they get to a side and they rely on their ancestral knowledge or what other people say. But what we found was if they have this actionable knowledge to suit a problem, they were happy to use it. So that opened up this whole area of how can we generate this actionable information. And if I take one of the questions farmers were asking, what are the suitable crops to grow? Then we went and asked agriculture extension officers and experts, what else do you need to know to answer this question? And what came was, which are crops suitable to grow in Dambulla area, which is a particular location. Or they were saying, what are the suitable vegetable crops for upcountry, again a location, available to the well-drained loamy soil, again soil characteristics with particular rainfall. And then what brinjal varieties can resist bacteria, wilt, disease. So when you are selecting a crop, you have to look at multiple parameters, and when we start asking experts what else you need, we started to create more context relevant, put these questions into context. And then we generalized the context as here, saying that grow in a specific location, grow within a specific soil type characteristics and other conditions. And once we start put this into the specific conditions, we were able to convert that into first order logic expressions, saying that for every crop X in the area, Dambulla grows, X grows in that particular area type, which gave the basis to start thinking of an agriculture knowledge or agriculture ontology to create the knowledge base, because we had to go to first order logic to answer these questions. So the actionable information notion was that yes, farmers have all the information through newspapers, leaflets, television, but the requirement was they need it in a specific context, whether to deal with a disease, harvest, or selecting seeds. And to do that, we have to map the whole knowledge in the domain into an ontology, and we created this ontological knowledge base, which is now available through mobile, and there is a website as well for people to come and look at that knowledge. And here are few snippets of this ontology. To answer the question, what crops will grow in my farm, because the farmer is using a mobile phone to ask this question, we take the geo coordinates, and from geo coordinates we map it into agroecological zone, and that gives us the environmental factors. On the other side, crop has varieties, but also the crops depend on particular environmental factors, and it has characteristics. So you can match the environmental factors So in other words, we can say what crops will grow in farm with these environmental factors. We get the answer and we can show them the list of crops that will grow in their farm. But it became a bit more complex when we had to work out the fertilizer. There were multiple parameters. Again, this is well published. I'm just showing these slides to show the complexity behind modeling that knowledge, and it was even more complex when it came to managing the disease and pests and weeds. But all that models have now been done, and we have this agriculture knowledge ontology developed and populated and created into a ontological knowledge base. So coming back with that detail, the question was then, how are we going to find this information? And certainly the ontological knowledge was quasi-static. That means they are changing slowly, maybe every 4 or 5 months or there is a new variety being put into the marketplace. And we found, yes, that enough published knowledge, we can reorganize that to create the scientific part of the knowledge base. But the other part was the dynamic or the situational knowledge, like is there a pest attack now, or what is the market price now, what is the current production levels now. Now to do that, we need to get the farmers engaged and develop transactional data, because we need to source that in real time and then do some post-processing to generate it. So the situational knowledge, generating the situational knowledge was a bit more tricky, but one thing that was very important was for farmers to be part of the system and start interacting and generating transaction data, like what they are growing, what they are planting, so that we can start extracting the situational knowledge as well. So the first thing is we started looking at this information need. We started with farmers, but we looked at people also in the area, like agriculture instructors, Department of Agriculture, Ministry of Agriculture. There are specific information needs, and then started mapping them in detail, the type of information they need, because farmers, agriculture extension officers and agriculture instructors, they wanted things like suitable crop varieties, possible pests and diseases. Then we categorize those into static information, or whether we need to generate them dynamically. Because thing is, the dynamic information, we had to discover some actions taken by some others in the marketplace in order to generate this. So after this mapping, we found, like, we had to expand. When you say crop, what are the parameters or the attributes? So that expansion was done. But then we found that by using two operators, this is the important part, aggregation and disaggregation, we can combine information generated by some stakeholders and generate information required by other stakeholders. That this mapping exists was a very interesting finding, that we were able to now map a flow model, which I will expand a bit more. So if you take at a generic level, the farmer wanted information from all the other stakeholders in the domain, and not only that, other stakeholders also wanted information from farmers and others. There was this dependency, and this dependency was based on not a direct dependency of information, but it has to be obtained using the two operators I mentioned, aggregation and disaggregation. So we were able to come up with much a simpler model of all these stakeholders providing information to a central processing unit, which can do the aggregation and disaggregation and distribute. So if you are familiar with the computer networks, from a mesh network, we have now gone into a star network with a lot more order and ability to manage. Then the next thing is, okay, the information is fine, but what will make users to use this information? Now, to do that, as I said, one of the PhDs was to look at the whole empowerment theory and how we can bring that into our system. Or in other words, we consider farmer not outside the system as part of the system, and we have to model their decision making process. And what we found was that you, me, farmers, everyone have particular level of competence, sense of control, motivation, and self-efficacy, and their goals and behaviors are depending on these levels of these values. If they are very competent with one method, obviously they will behave making use of that. Or if they are motivated, their behavior is different. And those behaviors get reflected in their decision making, identifying choices, autonomy to choose, and how they will engage and communicate. So there is this set of behavior components that is visible. And when they exhibit these behaviors, it impacts the outside system, and the system then provides an input to the farmers. For example, based on their competence, sense of control, motivation, self-efficacy, they might explore few things. For example, we found some farmers, when we went to the field, knowing this overproduction problem, will get into a motor bicycle, go around the village to see what others are growing, to decide what to grow. Some farmers went and had a discussion or chat with the seed suppliers to see what seeds being selling, and then try to decide something else. So they knew something has to be done, but didn't have the right information. But some farmers said, look, yes, my father grew this, my grandfather was growing this particular crop, I am going to grow it, and decided based on that. But whatever they decided, there was a feedback of a good price, a bad price, etc. And that will reinforce or bring down the value of these internal parameters. So this was discovered by one of the researchers. And these behaviors, then, we were able to map with our information system. Because in this side, there is this empowerment cycle, which I have shown in red, which exhibit the behaviors, and we mapped the information our system provides to support the behaviors so that they can make informed decisions. They can ask what questions, user query would be what questions to grow, what crops to grow, and the context filter will give all the environmental parameters. It will go to our knowledge base, and in this case the scientific knowledge is in the ontological knowledge base. It will do the matching I showed earlier. And it will give a list of crops on the mobile for them to, which they can grow in their farm. And then they can start asking how much it will cost to grow a crop, and for that they have to say how much they are planning to grow, and that will then go and find out fertilizer, pesticide required, and also the current market prices we feed into the system. They will get how much it's going to cost them to grow that crop for 1 acre, 2 acres. Then from a short list, they have to say, look, I'm going to grow carrot, 2 acres, action taking, and then they will be guided to grow carrots. But when they do that action taking, we add, yes, in this farm, 2 acres of carrots are grown, we aggregate and we generate the situational knowledge, saying like this is what is being grown in this farm, this is what is grown in this farm, and then we can use predictive models when we have enough samples to say, look, this is what will be grown in this region, this is what will be grown in this region. And that will then be indicated back to the farmers. I will show you some interfaces next, which are color coded to indicate when there is a saturation happening, that will change the behaviors. So here the empowerment cycle is happening, there is the information flow cycle is happening, and because of the situational knowledge, they can diversify the crops, and through that the market prices will be better, and that will reinforce this cycle. So there is the coupling not only through interaction but also through situational knowledge, basically better decision making, which will reinforce the behavior patterns. So we were able to link the human behavior and the information flow model, and I think this is a novel part, though there were a lot of work done on the empowerment side, but this coupling we have not seen in literature. So these are some of the interfaces of the system that was developed for the farmers in Sri Lanka, where farmers can log in, they see the main menu, then they need to register a farm because, as I said earlier, we need the geo coordinates, which they can either do through filling a simple form or they can select from a map. And for a registered farm, they can ask a question and they click on it, what crops will grow. And as I explained earlier, they will see a crop list. They can select some crops and start exploring further. And so in this case, tomatoes, the varieties are shown and the variety characteristics are shown. And based on that, they can start creating a shortlist. And once they get the shortlist, they can start go to the expense calculator and find out by entering how much they plan to grow, how much is going to cost for different stages of the crop cycle, pre-sowing, growing, harvesting, post-harvesting, etc. And also they can find out what fertilizer is required, pesticides are required, and the details, who the suppliers are, and once they select, they can figure out how much it's going to cost. So basically we managed to get them engaged, but in the process, we also found what they are growing at the planning stage. And that means when the next farmer comes, we can indicate to them that this particular crop is going to be saturated. And what we realized was once we put all together, this is where I said that we reconceptualized what we started as an ecosystem, is there was this whole dependency of information among one another, and it was a bit like a biological ecosystem where there is this small one cell life get formed, and then the next group of species come to consume them, and then the small fish come to consume them, the mackerels come and the big fish come, but when they die, there is the decomposers, the bacteria and microbes which decompose, which again give fertile ground for these the basic plant species to grow. So there was this similar dependency and this continuous cycle, which is in this case powered by the solar energy, and we started to see a similar pattern of information flowing powered by the empowerment flow in users, the motivation, etc. will keep the information flowing, because we see a lot of systems nicely designed but no information flows, and after a while they close down those systems, and in the literature we found many of those. So just to summarize this part, the whole notion now with this conceptualization of this as a digital ecosystem, it starts with the information need and a user context, and in order to fulfill this user information need in context, we need to organize the prior knowledge and do a disaggregation, breaking it into the ontological knowledge base. Then we can generate context specific actionable information. And when we do that, the users can act on it, and once we capture the action, we can generate the dynamic content. And the dynamic content, by aggregating, we can generate new knowledge, which is the situational knowledge, feeding back into the system. When this happens, this information becomes now valuable to others. For example, when the farmers started selecting the fertilizers, we were able to predict that in next month in this village, this is the demand for urea, this is the demand for MOP, and suddenly it became very valuable to the input suppliers, because they were able to start planning their supply chain, and they started joining the system. And when that happened, then the banks got interested to provide microfinance. So by reconceptualizing this as a digital knowledge ecosystem, we started to see an evolution pattern rather than a one-off steady state. and an information flow model that can facilitate, we started to influence our thinking. And then this aggregated knowledge will become prior knowledge after some time, which is the crops that were grown in the last 2 years, 3 years, 4 years, which will again provide a lot of insights and new knowledge into the system. That's why this evolved as a knowledge management system, where over a period of time, this will be more up to date with real information than what you find in books. So this is sort of the journey we took, and we came up with this invention, which is a digital knowledge ecosystem, as a possible solution to this overproduction problem. And then we started how we can now start deploying this on a large scale, and which is the second part of our journey, which is the innovation. And again, the roadmap for that was, as you said, we did the field trials from April to September 2015. So that was the starting point of our innovation journey. But by June, when major agrochemical companies saw what this system can do, they all in Sri Lanka agreed to provide their pricing through the system, because they saw that how this can spread. And in September 2015, Sri Lankan government got quite interested in this project and wanted us to provide a proposal to manage their agriculture. And in November 2015, in the national budget itself, this was announced as a national project in the 2016 national budget. And by January, we had major buyers signing up to invest in the phase 2 of this project, which is the innovation. And in October, we had Indian venture capital company talking to us, saying that what is the possibility of deploying this in India as well, because they also had the similar problems. And now we are getting ready to do a proof of concept trial in India involving 5,000 farmers in Telangana state, and this will start in September this year. So this is a sort of snapshot of that innovation journey. So as I said, that we now have a menu item in the Sri Lanka system, view prices, and that will take you to show the major agrochemical supply companies, and then you can go and look at their prices for seeds, fertilizer, chemicals, etc. But this is a very interesting thing, because when the Sri Lankan government said, look, we have this problem of overproduction and wanted us to see how it can be solved, we put a proposal, and this is infographics of that, because what our system, by this time we have given it a name called Govinan, or farm intelligence, where farmers make those decisions, and we can capture and aggregate about the food production, and they are all geotagged on a map. We can show what is happening where, which is the situational knowledge. That information can be fed back, and also we can feed in the market information, input on information on input suppliers, the various government incentives, crop knowledge, weather, microfinancing into the system, which will flow in here. But now, as I said earlier, the main controlling factor was the government incentives to manage the food production, and we suggested we'll develop some dashboards where they can actually monitor this and set the policy settings more or less real time to control the crops being grown. So from an open loop system, conceptually, it became possible to now design a closed loop system where farmers can make an informed choice and try to get this supply demand balance happening, integrating the input suppliers, markets, everything. So we put this proposal, and another very interesting thing happened in Australia when I was giving a seminar, and when I showed this slide to a group of health insurance companies, they immediately said, why don't you try taking out the crop knowledge and put in information about chronic disease management, the same system and the architecture will work. And that is what triggered this work on chronic disease management, which Laurette briefly mentioned. and actually they funded a PhD student, and we have the initial prototypes, but in this seminar I will not have time to talk about it. But certainly conceptually we had a solution to have a closed loop system to coordinate the agriculture markets. And this is the budget speech to convert from this open loop to closed loop. And the key points in that budget speech was they have acknowledged a mobile application to support efficient agriculture commodity production. And they said that for companies to work with us, high-end equipment acquisition supported with accelerated depreciation will be given to any company that is going to monetize this invention. And also the government said they will provide land or any other resource based on the type of project. So this is a very interesting position the finance minister took. Rather than directly funding, they encouraged a public-private partnership for this to go forward. And as a result, in the early 2016, some major buying companies started talking to us, and we started modeling their value chain from initiation, the various activities, the cultivation planning, harvesting, post-harvesting. And at this point, we realized that in the ecosystem, we can have sub-ecosystems and say, look, these farmers belong to value chain A, and it can be a sub-ecosystem within itself, a supermarket buying from farmers and managing their demand rather than a whole country. Another company which wanted to export gherkins to McDonald's in China was interested in this system. So we did quite a bit of value chain modeling to get this implemented. But interesting innovation which I'd like to share is this all top-down approach, because this is companies trying to develop this and try to introduce the farmers, actually met with limited success. One would think this will work, and that's what we thought, but they did not scale up to the degree I was like to see. And then some very interesting insights came from another set of research we were doing in the area of social computing. Because what we observed was there are these social computing applications which was started only about 10-15 years ago, but having communities now running into billions, like Facebook recently reached 2 billion, YouTube about 1 billion, the Blogger, all these, and then there were the business ones like the Airbnb now having a community of 80 million, and Uber still around 8 million. But these were very big numbers compared to the numbers we see on an agriculture system, but there are so many people who want this. So I started to think this whole top-down approach is not the best way to diffuse the innovation to reach the masses, and which started to think about the human needs and the Maslow hierarchy. And at the bottom we have the physiological needs, or in other words, what I say is I need to live now, I need food now. But if my needs now are met, we need to have the safety needs that I have these requirements met tomorrow and into the future. Therefore, we need to have a job, we need to have money so we can get those which arises from the safety needs. And when that is met, we need to be in a community, and the belongingness is required. And then we need to be recognized within the community if the esteem comes. And then once we have, like people like Bill Gates and all of them are giving back to the community, which is the self-actualization. And we realize that.
Athula, you're breaking up a little bit.
Okay. Any better now?
Yes, now it is.
Okay. What we realized was, if you look at the social networks, they actually map to these two levels of level 3 and 4, belongingness and esteem, because you are there to be within a group, and whenever we do a status update, what do? we keep going back and checking how many people like it, which is the esteem. Am I recognized within my peer group? And that was sort of a key for these large groups to get formed and those communities to get formed, and which led us to further exploration of various successful social computing applications. And we took the grey literature and started coding various causalities in that literature, and we found for all those applications there is a consistent pattern of causality that is beginning to emerge in that research, where the technology has enabled the application, and all the applications had, successful applications had 4 application characteristics, which is the aggregated knowledge, content sharing, social interaction, and business transaction. But for this to happen, there was this emergent characteristics of people feeling that they have trust, they have empowerment, and also the perceptions after using, saying they are efficient, user-friendly, which has then given rise to the use actions, users using it, which has given the business outcomes. And these insights of going through many of those social computing applications helped us to start mapping how we can fulfill that basic human needs. Starting from the Maslow's hierarchy, if you really think of it, to meet each of these levels, only the lowest level of I need to live now is something one can achieve as an individual. So if there is some danger now, we will, as an individual, will run to safety. But when you come to anything above, like safety needs, if we want to ensure that we have food or health care, we need to work in communities. And belongingness, self-esteem, all, if these to happen, we need to form into communities became clear. And also, basically, more, you will have a higher self-esteem if lots of people start liking you. So it sort of indicated more of an inverted hierarchy here of the size of the community to meet the needs. And then what we saw was once the communities are formed, there is the coordination and exchange of product, service, information tend to happen, starting from a small family, which is a community, and they just give, there is no formal exchanges, they share food, they share money, they help one another. But then that grows into more formal exchanges, which is the corporation and markets, where we need the formal exchange mechanisms, currency, trust. And the problem of here is that there is a surge cost, and the cost of these mechanisms in addition to the cost of the goods being changed, and there is a high transaction cost. And when we saw then, once the trust is established, they go into a trust bubble and they tend to work with the same group because of the trust, and the transaction costs come down. This was a very interesting insight, because going back to what we were trying to do with this top-down approach and the businesses creating the value chain, they were very much in these trust bubbles. They have existing farmer groups, and what they wanted to do is very much to make the processes here in the trust bubble efficient by using this technology, rather than thinking of empowering and generating communities. That became very clear. This gave me some insight as to why this top-down approach only had limited success. And this started to influence our thinking. And now we are looking at the field trial for India, and in the Indian system is known as Gayan Kisan, which is the translation of Govinana to Hindi. We started thinking of digitally connected farming communities rather than value chains, and this whole notion of building communities. And in India, pardon me, there's about 118 million farmers, which is the base, and there's existing farmer producer organization structure, and we have started working with them, and also those structures have got state level structures at the state level, and in Telangana state the head of state farmer producer organization is working closely with us for the field trial. Sorry. And then there's the possibility of National Federation of Farmer Producer Organizations, and we see the system we are developing for India, the entity is called Agribridge, basically helping this community formation by providing mobile-based application, and instead of this happening on a paper-based world, we are enabling them to happen it in a digital transformation. So you can start to see how the thinking has transformed from value chains to community building through that experience in our innovation journey. And then we were able to map a very clear value proposition for all the stakeholders. Again, the cornerstone is farmer empowerment and action. We need to empower the farmers. To do that, we need to have that context-specific actionable information. So at the moment, an ontological knowledge base for India is getting developed, and we can capture, aggregate, and start generating the situational knowledge. Again, the very first thing is we can map the current crop production and feed that back to the farmers to get that crop diversification. So in other words, at the farmer level, we are having an immediate value proposition for farmers to join the community. And once they join the community, we can make use of the situational knowledge and started aggregating and empower the farmer producer organizations and the cooperatives by giving farmer-specific aggregated numbers, and they can help farmers by providing local stock availability and local knowledge back into the system. And we can use the aggregated knowledge to connect the input suppliers by giving the aggregated location-based demand to plan their supply chains, and price and application, how to apply those chemicals, fertilizer back into the system. And we also can tell the buyers that this is what is being grown, and buyers can give requirements, and once we reach the trust bubble state, there will be forward contracting and things that can happen through the system. And a very interesting dependency was discovered when I was in Hyderabad in March this year, IFISAT, which is a research agency funded by UN, which is developing drought and seeds for harsh weather conditions, working in India and Africa. And when I was talking to the scientists, what they are saying is, what they said was, yes, we are developing all this, we test it in our farms, we put it into the market, but we have no information who is using it, how they are faring out there, and now the donor agencies are asking us to show the impact. And with this system, because if they provide the seed and crop information and farmers select those seeds, we can aggregate and tell them exactly where their seeds are getting used, how they are performing, and that will be very valuable information for them to continue their research, as well as show to the donor agencies the impact they are creating. So suddenly various people started to see the value in being part of the ecosystem, and that is where we are hoping to see that ecosystem will start to grow. And this is an interface of the Indian system we are developing. And suddenly I saw a very interesting connection of the new menus that have started to appear, because my crops and my expenses are the initial value creation for farmers, and that is what is going to encourage them to come and be part of this Gayan Kisan community. And once we have them in the Gayan Kisan community, basically in our thinking, we have started a My Calendar, which is to start coordinating not only their activities, delivery of fertilizer, pesticides, various farming activities, which will be the coordination phase to develop it. And then once they have that confidence and trust being built, like the My Orders, where they can start ordering because they have already started planning the crops and the expenses that will feed into the ordering module, and they will start cooperating with the others. And so first the information will start to flow, the material will start to flow, and finance will start to flow, and an interesting monetization model started to emerge in this Indian proof of concept once we started to think of grassroots level innovation and community formation. Then briefly, another project we have started doing in Africa is nutrition-driven agriculture to combat hidden hunger. And again, the problem there was they eat a lot of starch, but their diet lacks the vegetables and fruits which can provide the micronutrients like zinc, iron, vitamin A, C, and the result is a lot of health issues, which is the health and well-being side. And this image shows more than 70% of kids in Tanzania are stunned, because this line here should be the average height, and most of the children are quite short, but that also leads into all sorts of other health and well-being issues. But the interesting problem is, in these countries, this type of crops and vegetables can be grown, but people are not growing it because they don't know what will grow in their land area and how to grow it. And this project is done with 3 African universities, Pretoria, University of Nairobi, and Ibadan, and this is us at Western Sydney. But they are all coming from agriculture and agro economic side of things. And at Pretoria, they have found all these crops can be grown, but how do we start? How do we inform this community? So we are bringing in the knowledge we have developed from Sri Lanka and India, and at the moment we are actually identifying, the African partners are identifying the crops that will grow in different locations, and we are geotagging it. They have developed 16 questions to identify the food habits and to identify what is deficient and provide input, and that from those questionnaires put onto a mobile, we plan to identify the micronutrient deficiencies in their diet, and we can now match with the crops that will grow with the technologies we have developed, and we can identify what crops will grow in their location that is also can address the micronutrient deficiencies. And then we can produce a list of crops that will grow in those locations, but we can go further because of the work we have already done and provide the nutritional value as well as how these crops will grow. So this is in very early stages. This project started beginning of this year, and at the moment we are again geotagging and collecting these knowledge bases to bring this know-how and to help the African nations as well. So with that, if I come back to where I started towards achieving the Sustainable Development Goals, what I'm beginning to see is that context-specific scientific and situational knowledge is in the center, and if we can get this piece done, we can then use it for user empowerment. And the empowered users will then create a market coordination rather than being dictated. They will be free to decide what to grow, but with this informed knowledge and empowerment, and that will then give rise to an effective, efficient, and sustainable agriculture sector, which can then impact on fighting the poverty, hunger, and good health and well-being. So I'm connecting it back to the point where I started, how this can be sort of a basis, but this needs lots of effort and a lot of collaboration, and I think a whole group, the whole world, if we can collaborate, we can get some outcomes. And finally, I want to sort of finish this on this note, another interesting connection and thing. because there are so many apps and systems in the marketplace, and they tend to give information to the speaker. But what we saw was, all the information needs are connected. And not only that, they should be able to give information back to the system, and we need to create this whole flow model, which can then give rise to the increased productivity, sustainability, wealth creation, and user empowerment. If you really think of it as the last thought, if you look at the mass production, what Henry Ford started with the mass production chains, where the work was brought to the worker, and which enabled assembly lines. A lot of work people were able to participate in the production process. The digital knowledge ecosystems has the ability to bring knowledge to the worker and enable them to participate in the whole production work in a coordinated way. So this could even be an equivalent of that assembly line of the industrial age when we go into the knowledge economy. I think with that, I will stop and open up for questions.
Okay, for questions, I've muted everybody. If you want to ask a question, please unmute yourself or ask the question in the chat box.
Can you hear me?
Yes, I unmuted you, Laurette, already.
Okay, perfect. So let me start the discussion. Thank you so much, Athula. That's excellent work and excellent and very complete presentation. We are already 5:15 local time with 15 minutes to go. I have a series of questions, both substantively and strategically. But before that, let's first see from the virtual floor if there are questions that emerge. Can you unmute everyone? And if someone wants to ask a question, please identify yourself and ask the question. And if there are no questions from the floor, I will ask a series of questions. Are you unmuting? Yeah. Okay.
It's easier. They should be able to unmute themselves by clicking next to their name, the microphone next to their name to.
Okay.
If not, I can try. If we unmute everybody, it could get.
Okay. Okay. So, any questions from the floor? No? Okay. We will start, and if some wants to ask, put a chat room or unmute yourself. Let's do it as we start the question. I was very interested by you're making the point that by creating this ecosystem, you were shifting the supply-demand type of from an open system to a closed-loop system with different consequences both for the physical operation, but also with the digital. And I'm not a systems modeler. I would be very interested to know a bit more about what we mean by this and how it relates to the functionality of digital backbone if we are able to go further in that direction. That's my first question, Athula.
Yeah, so to me, the problem is, at the moment, if you look at that whole sector, we don't know what's happening until the crops come to the market. But with the digital ecosystem model that evolved, from every stage, we are monitoring what's happening and we can generate the situational knowledge. And that, if that is available to the stakeholders in the right format, because for some it will be the need for microfinance, for some it will be the need for various inputs, then obviously a lot of storage waste can be avoided by first matching the supply and demand for the food, then for the inputs, then also making sure the right amount of money is being made available to the right people at the right time. So digitally, that's what's happened, but then it will have the physical consequences on the physical world of how do you plan your supply chain, the storage, distribution, etc., which in turn will reduce the waste and minimize that 40% waste. At least if we can minimize it by 10 to 20%, that's the major achievement.
Okay. So my other question is also along the technical side. When you had your journey diagram where your system is anchored in what you define as a user-centered ontology. And I'm kind of intrigued to see, if you look at agriculture and all the various streams of science and knowledge that you need to have on the crops and on the climate, on the seeds and so on, so you get that kind of quote-unquote objective knowledge there that needs to be codified in some way. And how do you then bring in the user center that will be very, I would suspect, uninformed by all the science? So just if you could elaborate a bit on this in the development of ontology from the perspective of complex scientific or knowledge domain to be looked at from the angle of the user. So what are your thoughts there?
Yeah. So this slide, which I'm going to now quickly get to, summarizes that process, but it is a lot of intermediate steps have been not explained here. But what we did was, when we said user-centered, there are call centers in most of the countries to help farmers. And we went and interviewed the people in those call centers, and some have kept logs of frequently asked questions by users. So we got the list of questions. So that's where it's what they want, what are the problems, answers they want on a day-to-day basis. Then we went to the experts and said, look, yes, you have all this knowledge, what you mentioned. Now, how do you select an answer to this question? What else do you need? And then the experts said that, yes, we need to know the climatic condition. We need to know the soil parameters. We need to know the way it is being irrigated, whether it is rain-fed or irrigated through pumps. So they gave us a list of things they will consider when answering the question. And from that, we said, look, to answer this question, you need to identify the context, which is the second column. So from specific, then when we look at the specific context, we can generalize and say, look, it's to do with the location, it is to do with these parameters. And from that, we were able to generate first-order logic expressions of also in ontology known as competency questions to shape the ontology as to what type of answers needs to be developed in what context. And then we use this to identify the various classes, the objects, the object relationships, and model the domain in a way where we can use these queries, first order logic queries, which we are using through a Sparkle endpoint at the moment, to answer it. So it's a very tedious process. And also, at the moment, we are trying to do the same for India. There's so much very well researched information, even for us having the knowledge, just to find that takes days. So there's no hope a farmer is going to spend all that time, and extension officers or experts are hard to find because there's not enough experts to farmer ratios. They are far away, and therefore the flow is very inefficient. So more we can digitize that knowledge to answer those questions with farmers are asking, then we can achieve better outcomes and more utilization of that knowledge, which would result in better production outputs.
Thank you. One last but possibly challenging question is that in all of your example and your exposition, you were talking about the farm and the unprocessed product, fruits and vegetables and so on. And when you look at the post-harvest, it is typically very, very farm-level type of very primary processing that can be there. When we talk about food, even in quote-unquote developing country, very, very early in the development, food is not kind of completely contained within the agricultural system. It is about the food manufacturing, retailing, and there is a very important additional layer of complexity that needs to be accounted for. And food is also, when you were talking about doing the work on the farm and then separately doing work on chronic diseases, food, the diet, is the most significant controllable risk factor for chronic diseases. So when the group behind this webinar is very much about saying, if we see, for a part of the work, if we see food as at the nexus between agriculture, industry, and health, and food security, and so on, we will need to develop an integrative backbone that bridge the farm and the agriculture as you have, and the food in both its more complex nature and its outcome for environment or for health. So where do you see, I'd like you to react to whether what I'm saying makes sense, but then where do you see not just your work, but the work on building a digital, this kind of digital architecture to help make a 21st century with sustainable development and nutrition security and so on? Where should we go as an interdisciplinary, scientific, solution-oriented community, both academic or industry for that matter? So back to you, Athula.
I think what you said is very important. It's a much bigger picture with all the processing, supply, delivery. Now, but if you look at this slide, each part at the moment have their own mechanisms in place. They are processing, they will try to have the farms, the markets, so that is the domestic and export market loop. And then here is where the production happens. Very often, because they can't control, they have got contract farming happening, which is limited in that sense. Now, obviously, it's, as you said, it's very big field, but the problem is these are not connected. Like the flow of information between these circles are very limited. If you are saying food processing, they will have all that, but they have no control of their inputs, and the way they manage at the moment is having their own contract farmers, which is limiting their capacity. And if there is a deviation due to weather, etc., there is no fallback. But if we can have the basic ecosystem, that ecosystem can feed into many sub-ecosystems, which I briefly mentioned when we started modeling the value chains. But this system would be the base system which will provide the essential information between supply and demand, so that we can optimize each of the systems. So that system level thinking and getting the basic connectivity back to the farm becomes quite important. And then there's lots and lots of research that has to be done on top of it, but I'm seeing that big picture of the ecosystem doing that basic bridge. And then sub-ecosystems can evolve within it to manage all that, and then from food production we can look at dairy and other areas as well. But very interesting patterns have emerged which I'm sharing with you all, because the effort required is lot more than what few individual researchers can do.
Oh, absolutely. Okay, one last invitation for anyone on the virtual floor to ask questions. If you want to unmute yourself and ask a question.
Hi, this is Sean. Can you guys hear me okay?
Yeah.
I just had one question about the ontologies. You had said there's user-focused ontologies. How much of your ontological development is homegrown, and how much are you using, say, other already developed ontologies out in like the web of webs? I'm just curious as to how much you've reused and how much you had to home grow your own ontology.
We couldn't use much of the existing ontologies like the Agribusiness, etc., because the relationships we were looking were not there. So finally, basically, we have to home grow bulk of it after exploring all this, and then we have opened this up, the endpoint to public for them to be part of it. But it's very much homegrown after looking at other ontologies available. They were not for the specific user-centered purpose, but they were just modeling the scientific knowledge. But the relationships to answer the queries we had coming from the user questions, we couldn't get it. So it's very much homegrown.
Okay.
In fact, there is a journal article which explains all that, published by Elsevier.
Okay, great. Thank you. Thank you very much. Very nice talk. Thank you very much.
Any other questions? No? So thank you so much, Athula. That was an excellent and important presentation. And I kind of anticipate that we may be building on your wealth of experience and know-how in that space as we are moving toward this, looking at this more complex nexus, food at the nexus of agriculture, industry, and health. Thank you, and thank you, Athula, again, and thank you, everybody, for your participation. A reminder, August 2nd, now back to our regular time at about o'clock Eastern time. My colleague from McGill, Nathan Young, who is a consumer choice modeler, microeconomist, who will be bringing a big data and analytical approach on some application for weight loss. Very different domain, but still this combination of big data analytics and kind of the science of behavior, business, and society. Thank you, everyone. Bye-bye.
Yes, thank you, and bye-bye.
Bye. Thank you very much. Very, very good talk. Thank you.